Find the following limits if they exist. In part A, we got limit of this rational function. As usual, we simply try to plug in. Unless we get 0 over 0, that's our answer. Let's plug in 1. We get 1 is squared, which is 1 minus 1, 0 on the top, over 1 minus 1, 0. Okay, we get 0 over 0, which is an indeterminate. That means if we graph this function, there is a hole on the graph at 1. That means limit still exists. So let's find the limit. For we need to simplify. Factor the top, factor the bottom, cross out the common factors. So this is then limit x going to 1. So we need to keep writing this until we use it. So on the top, x square x, we can factor x out. That leaves x minus 1. You can check by distributing. On the bottom, x minus 1. Okay, now x minus 1 cancel. Only x left. Now we replace x by 1 because x tends to 1. So here is x. So this is 1. Okay. Part B, same thing, plug in negative 1. Negative 1 is squared, which is positive 1. Minus 1. Negative 1 is squared. So negative is squared will be positive. So this is 0 on the top. Negative 1 plus 1 is also 0. Same like part A. We need to factor the top, factor the bottom. Bottom is already factored. Cross out the common factor. Then plug in. So limit x going to negative 1 of, on the bottom, x plus 1. On the top, let's factor this. That is x plus 1, x minus 1. X plus 1 cancel. Okay, now plug in x equals negative 1. So here is negative 1 minus 1. Negative 1 minus 1, that's negative 2. Plug in 2. 2 is squared. 4 minus 4, 0. Over 2 minus 2, 0. Same story. Factor the top, factor the bottom. Bottom is already factored. X squared minus 4. We know when we have u squared minus v squared, it's the difference of two squares. It factors as u plus v, u minus v. So x squared minus 4. 4 is 2 squared. So this factors is x plus 2, x minus 2. Now x minus 2 cancel. Replace x by 2. So here is x. So 2 plus 2, 4. Plug in 1. So 1 is squared. 1 minus 3 times 1, 3 plus 2. 1 minus 3, negative 2 plus 2, 0 on the top. 2 times 1, 2 minus 2, 0. So 0 over 0. So we get 0 over 0. That means more work. So we factor the top, we factor the bottom as usual. So on the bottom, it's only 2 factors out, x minus 1. Okay, this is a trinomial on the top. So we need to factor is a product of 2 binomials. So x squared, x times x. So plus 2. So we need to find 2 factors of plus 2 that combine and give negative 3. So 2 means 2 times 1, 2. Negative 2 times negative 1. Positive 2. And negative 2 and negative 1 make negative 3. So it does not matter which one you write first. Negative 2 minus 1. Now x minus 1 cancel. Replace x by 1. Plug in 1 here. 1 minus 2. Negative 1 over 2. or negative 1 over 2 is same as negative 1/2. Okay, now let's go to part E. Plug in negative 2. Negative 2 is squared, positive 4. 5 times negative 2, negative 10, plus 6. 4 minus 10, 4 minus 10, negative 6 plus 6, 0, over negative 2 is squared, positive 4, plus 2 times negative 2 minus 4. So anyways, it's 0 over 0. That means more work. We need to factor the top and factor the bottom. Bottom is easy. We can simply factor x out. That leaves x plus 2. Okay, x out, x plus 2. On the top, it's a product of two binomials. So x squared, x, x. Now 6, 2 times 3, 6. 2 and 3 make 5. Everything plus. Okay, so plus 2 is a plus 3. So you factor in this way. Now we can see x plus 2 cancel. Now replace x by negative 2. So negative 2 plus 3. Negative 2 plus 3 is 1. Okay? Negative 2 plus 3 is 1 over negative 2. So 1 over negative 2 is same as negative 1/2. Because negative pulled to the front. In part F, plug in 3. Same story. 3 square 9 minus 15, negative 6 plus 6, 0. 3 square 9 minus 1, 0. So 0 over 0 means we need to factor the top, factor the bottom. X square minus 9 is like here, x square minus 1 or x square minus 4. Okay, difference of two squares. So x square minus 3 square. It's a difference of two squares. So x plus 3, x minus 3. On the top, we got two binomials. X square means x times x. 6 plus 6, we have to get 5. 2 times 3, 6. 2 and 3 make 5. So 2, 3 or 3, 2, same thing, to get minus, both minus. Now we can see x minus 3 cancel. Replace x by 3. 3 minus 2, 1 over 3 plus 3, 6. So the answer is 1 over 6. Don't go for decimals. Okay, this is x going to infinity. So this is infinite limit at infinity. X going to infinity, limit at infinity, limit at infinity. So these are different. So pretty much these are easier. So when x goes to infinity or negative infinity, only the leading terms matter. So in this case, this limit is same as leading term, means highest exponent term. 2x cube on the top, 6x cube on the bottom. X is so big, only the leading terms matter. I mean, this procedure does not work for these questions because x is not going to infinity there. Okay, here x approaches to infinity, means x is so big, only leading terms matter. Okay, that then now we can cancel x cube. That leaves 2 over 6. I don't have to even plug in because there is no more x's. 2 over 6, which is 2 goes once, 2 goes 3 times, so 1/3. Okay, same thing here because x goes to infinity. So limit x approaches to infinity. On the top, leading term 2x5. On the bottom, leading term 3x to the 4th. So let's simplify now. 5 copies of x, 4 copies, we can cancel 4 copies, just 1 copy left on the top. So 2 1 copy of x over 3. Now replace x by infinity, as the x approaches to infinity. 2 times really big, infinity means really big, 2 times really big is really big, divided by 3 is still really big. So the answer is infinity, or we can say this limit does not exist, but infinity is better answer. Similarly, since x approaches to negative infinity, only the leading term, so 5x to the 4th over 2x to the 5th. Okay, now cancel the common factors. Okay, x to the 4th, x to the 5th, 4 copies cancel, 1 copy left, so 5 over 2, 1 copy of x, 5 over 2x. Now, because there is no more x on the top, so replace x by negative infinity, so big on the bottom, negative really big, it's the really small but in negative really large quantity, so the bottom is very 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 big but in negative, and number divided by very 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 big is very small, that's 0. Okay, so the answer is 0. So this is like negative 0, but negative 0 and 0 are same, so the limit is 0. Okay, when x goes to infinity on the bottom, and number over infinity is 0. Final.